Awesome. Okay. All right. So I hope all is well. I hope you had a nice week. I hope the homeworks are making sense. And again, if they aren't, please let us know or go to Kyle's office hours. Um, so up to this point, you've learned how to like load and edit Google Colab notebooks. You've learned the basics of Python and NumPy. You've used the Pandas library to load simple.csv datasets and run simple tasks using, or such as finding values using dataframe.loc or dataframe.iloc, or cleaning our dataset by removing null values using df.dropna. And all of these are very, very crucial to what we're trying to achieve in the end. So you've probably seen visualizations all around, and you've probably used it for like work or presentations. So now with this lecture, you should be able to visualize data sets that have more information in columns. Awesome. So what is data visualization? Data visualization is when you're given a data set or when a given data set is presented in a graphical form. It helps us in detecting patterns, trends, correlations that usually go undetected in text-based data. So in simple terms, we will use a data visualization to explore data and to communicate data. Why we should use data visualization. So as the world becomes more connected due to an increasing number of electronic devices, the volume of data will also continue to grow at an unprecedented rate. Data visualizations make big and small data easier for the human brain to understand, and visualization also makes it easier to detect patterns, trends, and outliers in groups of data. So it's very important for any career. So from like teachers trying to make sense of student test results to computer scientists trying to develop the next big thing in artificial intelligence. So how we should use data visualization. So good data visualization should place meaning into complicated data sets so their message is clear and concise. Whether you use a basic bar graph or an intricate infographic, data visualizations make large amounts of numbers and statistics accessible to both business holders and their audience. So it should be used to influence your decision making, and it's especially important when trying to analyze and implement strategies to improve. So for example, a website. Visualization makes it easy to ensure your website is as optimized as possible. It can also help you begin to ask the right questions, and it makes the data more memorable for stakeholders. So today we'll be working with I think 2 data sets. One is the stock market index data set, and it has 5,473 rows and 10 columns. So the shape is 5,472 and then 10. The first column is the date time ranging from 1990 to 2012. And the remaining 9 columns are numerical values that indicate the stock prices of companies such as those companies. You can see a few big ones like Apple and IBM and Microsoft and stuff like that. So our second data set that we'll be working with is California housing information. So this one is information from the 1990 California census. So it may not help you with predicting current housing prices, like the Zillow Zestimate dataset, but it does provide an accessible introductory dataset for teaching people about the basics of machine learning. So in this dataset, they have a lot of columns actually, and this includes like longitude, latitude, median age, or housing median age, total rooms, total bedrooms, and other things like that. So our goals for today, we will learn how to build a plot step-by-step using Matplotlib. We'll be loading data sets using pandas and visualizing selected columns. We'll be using the stock market data set to visualize trends in data. We'll be breaking down the matplotlib function pyplot.plot, and then an introduction to pandas, as well as plotting simple relational graphs such as line plots, scatter plots, and histograms. Yeah, and then at the end, there will be like a tutorial, like a full tutorial of like how to work with data from beginning to end and like make a visualization for it. All right, so first we'll start with matplotlib. So it's a library in Python that does like two-dimensional plotting, so like X and Y axis. So it allows us to generate some simple plots like line plots, scatter plots, histograms, and bar plots. So in our case, we'll be using a specific set of functions. So matplotlib.pyplot. If you want to look more into this, there's a link here that you can visit later. And just to note, so this is not a part of like the core Python library. So if you'd like to use it, you'd actually have to run this in your terminal. Yeah, so there are a few ways that you can, once you do run this command, you can do, this is like how you import it. So you can do from matplotlib import pyplot as plt, or you can do it in this form. They're the same exact thing, just to show you that we can run both and everything will be fine. So with matplotlib, there are two main methods of plotting. One is a functional method. So using the basic matplotlib command, we can easily create a plot. So if no plot was displayed, or if you're using matplotlib from within a Python script, don't forget to add plt.show to display your plot. So this is one method. Again, it's functional. So you just keep calling plt dot and then whatever you're trying to do. So dot plot, and then you would have some arguments, and that would plot the x, y, your colors, and maybe other arguments. You can do plt.x label, which will set the x-axis label, .y label, y-axis, set title. You know, it's kind of self-explanatory. So that, again, that's one method. And then the other method is the object-oriented method. So the object-oriented method offers another way to create a plot. The idea here is to create figure objects and call methods for it. So to create a figure, we use the .figure method. And once you created a figure, you need to add a set of axes to it using .axes method. Okay. So again, this is the object-oriented method where we create a figure using plt.figure, and then we'll be doing things to that figure, unlike before when we keep calling different functions on plt. So for example, here, first line, we create a figure. Then we'll call fig.addAxes, in which you can add like the left, bottom, width, height, and just like a bunch of different arguments pretty much. And then you can call .plot, which will plot what you just made. And then you can set the X label, Y label, and your title. And again, they're the same thing. It's just whatever you prefer. So the code might not make too much sense right now, but throughout this notebook, we'll be going through these methods step by step. For now, the good thing about these two methods is that the output is the same. Yeah, they're just two different implementations. So now we'll go into pandas. So to import it, you just do import pandas as PD. We'll run that. So matplotlib is a fairly low-level tool, and this is because its main purpose is to draw simple plots involving numerical data. So for example, a line, plot, bar plot, box plot, scatter plot, and contour, and the simple plots. And then like you can add a legend, a title, and tick labels. And by now you've noticed that we've repeated the names of the types of plots a couple times, and this is because there are a few fundamental concepts to understand, and the most complex graphs, such as 3D, are built on top of these. So with pandas, we have multiple columns of data with row and column labels. Pandas has built-in methods that simplify creating visualizations from data frames and series objects. So another library is Seaborn, which is a statistical graphics library. We'll be using Seaborn in the later half of the course. Okay. So one of the biggest benefits of using pandas is the method of loading data files. So in our case, pd.read_csv as a data frame. It makes our work efficient and saves us more time to play with the data sets. So now we'll go into actually loading a file so we can work with it and create a visualization. So here, the first line of the code loads our data set as a CSV file. So that again, that's URL is equal to this long URL here. If you want to see what that looks like, I think I actually have it open. Yeah, so we just took this straight off of GitHub and it has like all of the data. Yeah, so you have your rows and columns and all of that. So we set that equal to here, and then by doing pd.read_csv and then the URL, it'll read through all of that data. And then when we do df.plot, it will create a plot for it. So there we go. Yeah, so although this graph is not correct, it gives us a complete plot. So the x-axis actually doesn't make sense when you think about it. So yeah, but here we go. We have a nice plot and it's all color-coded and beautiful. All right, so a series has the same data structure, or has the same structure as a data frame, but the main difference is that instead of multiple, there is only a single column. So if we were to plot each of the columns above individually, we would be plotting a series. So again, like if we were just to plot one of these, that would be a series. Yeah, so here we'll plot a series in which we'll only be calling AA. And again, I think AA, yeah, it's one of the blue ones down there. So when we plot that, yeah, so this is actually what it looks like. It's just by itself. So in the plot above, there are some important points that we should observe. The series object's index is passed to matplotlib for plotting on the x-axis. In our case, our object is dfaa, which the column names AA and our data frame df. And then the x-axis and y-axis properties can be modified using xticks, xlim, yticks, and ylim, and we will be talking about those later. All right, so working with time series. So first we'll run this df.head, and this will actually give us what we're looking at. Again, it brought this over from the long file of data. So this is a data set that we loaded previously, but there's something strange about it. We have an index column at the far left of the table. However, right next to it, we have the date and time columns, which hasn't been named, and the column value 0. So they're talking about unnamed this, and then these indices over here, as well as the date and time column. So this means, or what this means is that the column with the index value 0 can be the index column. So therefore, we can get rid of the leftmost headerless column, which is the current index. Luckily, this can be fixed when we load our dataset using pd.read_csv, and we'll be making 2 changes. One, we have to add a parameter index_call and equate it to 0. This signifies that we want to assign the index to the column with ID 0. So again, the most leftmost one. And then we set parse_dates equal to true. So this is important because the data frame doesn't know that the index column is a time series column. Currently, it's a string without any date-time properties. And fortunately, this function converts the strings to a date-time category. So when we call .read_csv now, and then we supply the URL along with the 2 arguments that we listed before, when we run it and then call head, we get what we wanted. So it doesn't have these indexes over here, as well as like these are what we're mainly looking at, so the dates. All right, so yeah, and then we can call df.dtypes on it to see that indeed we have float 64s instead of like strings, which we might have been working with before. Yeah, so now we know how to make a simple plot for a data frame in a series. However, in most cases, it's useful to plot multiple plots side by side, and this is done using plt.figure. So just a note, remember that PLT is actually matplotlib.pyplot. So we're calling the figure method, which is located in the pyplot class in the matplotlib package. It sounds like a lot, but just know that it sounds like a lot, sorry. Since PLT is a class, we can simply add methods to the object by using class.method annotation. So here we can call .figure on PLT, and let's just run that. So let's dive into PLT.figure. It has several parameters. In our use, fig size is very important. This will guarantee that the figure has a certain size and aspect ratio if it's saved to a disk. So note that in Colab, nothing will be shown until a few more commands are entered, and we cannot make a plot with a blank figure. Therefore, we will create one or more subplots by using add_subplot. So here, we're gonna create a subplot, and let's just run that. So we have a little plot now. We are transforming our original fig to a 2-row and 2-column figure. That's what these numbers are here. And then we're placing the plot AX to the first row and the first column. In total, this means that there will be 4 plots, of which we have selected the first. So if we create the next 2 subplots, we will end up with something like this. So we have 3 subplots. And then like, again, this is the first one, this is the second one, and then this is the third one. All right, so the plt.plot function. So when we call that on a data frame, let's say AA, this is actually what we get. So I believe we did that above. Above the PLT is a class we are calling. Plot is the function/method inside of the PLT class, or function/method inside the PLT class. Inside the plot method, we define the parameter to be df_AA, which means the column AA from the data frame df. And so when we run this command, it plots the column with respect to the index, which is date time. So as you can see at the bottom, we have our date time, and then, yeah. So next, we will run all the commands together. One slight change will be adding a subplot. So again, this is what we did above. We created a figure, added our subplots, and now we'll be plotting df_AA. Awesome. So yeah, now we have 3 plots. And notice how we did not actually tell it where to put this or put the information of AA, like which plot to put it into. It just automatically took the last plot. Yeah, so here's a now try this. I guess we can do it maybe like the first 2, and then the rest you can try it yourself at home. Yeah, so it's asking us to use the AX1.plot to plot the data set for df_AAPL, and then plot the data frame for GE on the 3rd axis. So yeah, so I guess we can do that really quickly. So what I'm going to do is go above, copy paste, because that's honestly what a lot of coding is. So just to save some time, we'll do this. And then it's asking us for to plot the data set for AAPL. So in order to do that, we would just add PL in there. And then, does it say where it wants to go? It says that we want it to be AX1. So in order to do that, I will change it from PLT to AX1. And then it's also asking us, oh, just to show that it's working, so it took the information from the AAPL column and plotted it in AX1, which again is just like the first little thing in there. And then it's also asking us to plot the data frame for GE on the third axis. So to do that, I'll do AX3, because again, that's our third axis, and then we'll do fig dot add subplots, and then we'll do, what is it, 2, 2, 3. Cool. Oops. Oh, wait. Oh, yeah, I was not looking at the right thing. Hold on. So we're just going to copy and paste. Okay. And then we'll do GE. There we go. That should work. Awesome. So yeah, now we're able to put the information from GE onto the third graph. And again, sorry for that. I was looking at the wrong thing. All right, so now we'll go into colors, markers, and line styles. So by now you've probably noticed that the main function you're using in matplotlib is the plot function. This function accepts arrays of X and Y coordinates and optional arguments such as color and line style and figure size. So this is an example. So in addition to X, Y, you can allow some other things like that, which we'll get into later. So we can show the same plot more explicitly by adding a line style. So we can say line style is equal to the double dash, which is just a special thing for one of the line styles. Line plots can also have markers in order to highlight the actual data points. So when matplot creates plots, there are a continuous line plot. So interpolating between points. It can occasionally be unclear where the points actually are. So markers help us observe the interpolation in a clear manner. So they use that because it's a more mathematical term when it comes to plot points. So here is an example. They create a figure, make two subplots, and then here is an example of them actually adding different arguments. So this right here, plot 2, or this line is the same thing as explicitly saying color is equal to B, line style is equal to dash dash, and marker is equal to 0 or O. So when we run that, so as you can see, there are a lot, I guess you can say like line style is bigger, more thick, you can see it. And the color is now blue. So again, when they use this color is equal to B, I said it's blue. So those are different things you can do for it. So for line plots, we can notice that the points are interpolated linearly by default. We can change this by using the draw style option. And this draw style determines how the points are connected. So here, we're plotting IBM, changing the line style, and then also the label. So, or draw style, there we go. Yeah, so again, this looks a lot different from what we just did up there. So here is another now try this. I guess we can do this one too. So it wants us to create a new plt.figure with an added parameter fig size is equal to 20, or is equal to 2010. So we create two separate plt.plots with those data frames. Yeah, I guess we can do that really quickly. Okay, so again, I will be taking code from up there. I guess we don't need. Yeah, and then we'll be altering it to fit what it is asking for. So here, again, it says creates a PLT figure. So that's what this line is with an added parameter fig size. So in order to do that, I believe we just put it in there. I guess we can get rid of that. And then it says create two separate plots with one with the data frame AAPL and the other one with Microsoft. So yeah, we can also do that. So we can say this is AAPL. Oh, that one's already AAPL. Okay, so we can make this Microsoft. And then it says for the first plot, set the line style as 1-. We can do that. And then, actually, hold on. Am I doing this right? Let me copy this one instead. Hold on. Okay, so let's do that. All right, so let's change this AAPL and then the other one Microsoft SFT. Make the line style for the first one 1-. Set the color to B. So color is equal to B. Label it after its specific stock. So we can say AAPL. And then for the second plot, line style as $. So we do that. Color is G. Color is equal to G. Yeah, comma. And add a draw style. So here it already has a draw style. Get rid of the label because they didn't want that. And then also it says add plt.legend. So we just do plt.legend. And then we would do AX1, I believe, and then AX2. AX2. So let's try that, see if that works. No handles with labels found to put in legend. Okay, well, I guess I would have to do something different to that. But pretty much this is kind of how you would do that. Again, I was just changing variables or some of the arguments, and yeah, so hopefully that makes sense. If you don't, again, please come to me with questions after. All right, so moving on, we can also add ticks, labels, and legends. So the pyplot interface designed for interactive use contains methods like xlim, xticks, and xticks labels. These methods control the plot range, tick locations, and tick labels. There are two ways to apply such parameters. So the first way is there are no arguments called, and it returns the current parameter variable. So for example, plt.xlim returns the current x-axis plotting range. And then the second one is called with parameters sets, or it's called with parameters, and it sets the parameter value. So for example, this one you would call plt.xlim, again, with parameters, and it sets the x-axis range from 0 to 10. So let's look at this. So we created a figure, added a subplot, and then we plotted AA. This is what we get. Again, it's so big because we did fixed size 20, 10. So next we're going to change the x-axis ticks. It's easier to use set ticks and set ticks labels. The former instructs matplotlib where to place the ticks along with the date range. However, we can set any other variables as the labels using set_xticks labels. Okay, so here we're going to use set xticks labels to label the ticks 1, 2, 3, 4, 5, 6, 7 instead of the years. So when we run that, okay, yeah, we just set it equal to not actually like update it. All right, so the rotation option sets the xtick labels at a 30-degree rotation. Lastly, set _x labels gives a name to the x-axis, and set title the subplot title. And so here we set the title and then we call fig. This is what we get. Here we have my first matplot plot, and again it set the title to that. And then as we did above, it set the years to 2, 3, 4, 5, 6, 7. Yeah, and then we can set the X label to stages, and then we can call fig so we can see it. Here we have stages, awesome, on the X axis label. And then we can also plot GE and then call fig again So now we plotted GE on the same graph. Yeah, awesome. So you can also write it as this, where you set props equal to like the different properties that you want to have. It's just really whatever you're more comfortable with. So again, here's a now try this. Please try these later and let me know if you have any questions. I don't want to take too long on this. So now we'll go about adding legends. So legends are an important element in order to identify our elements. The easiest way to add one is to pass the label argument when adding each piece. So for example, here we have a figure, and then we will plot, let's say like Microsoft. We would add the color B or blue, add a label, and then yeah, do that the same thing for Apple, add like a different line style and then add a label. And then for GE, we would add G dot, which is actually green dots as indicators, and then add a label. So when we run that, whoa, yeah, so here we get a big plot specified with each of the like the styles that we just went through. So that's really cool. And then adding a legend, so ax.legend lock is equal to best. And pretty much the lock method just tells matplotlib where to place it. If you're not picky, best works. So here we set lock equal to best, and then we call fig. Yeah, so instead of having, oh, actually this one didn't have a legend, but pretty much it just picked this because maybe it has, I don't know why I picked it, but it just added the legend there. So we can save active figure. We can save the active figure to file using plt.savefig. This method is equivalent to the figure's object savefig method. So for example, we can do plt.savefig and then like the fig path. So we'll actually have an example down here, I think. So note the file type is inferred from the file extension. So for example, if we use .pdf instead, we would get a PDF. Some important options are DPI, which controls the dots per inch resolution, box inches, which trims the white space around the actual figure. And then, yeah, you can pretty much put those in the .savefig like so. So here I sent the DPI equal to 400 and then the box inches to type. Yeah, so now we can save the previous graph by simply running this. Save fig, this is the actual like path of the graph that we just made, and then yeah, cool. So yeah, awesome. So in terms of types of graphs and charts, again, we went through a bunch of them earlier, just the names, and now we'll actually go into the specifics of them. So here, let me run this. We have a list of years, GDP, and then we want to create a line chart. So we'll set the x-axis to years and the y-axis to GDP. And then when we want to plot it, we call plt.plot, put on our x-axis, which is years, our y-axis, which is GDP. Just for fun, we want to make it red with X markers, and then we want a line style of solid. So once we specify all these things and we add a title, nominal GDP, and then add a Y label as well. When we call plt.show, this is what we get. Again, it's with what we specified. And just a note, like, you do not have to memorize any of these, like, what do you call it? Like arguments. They're really easy to find online. And again, you can always refer back to this, this file, this Colab. So it'll always be here for you. You don't really need to like memorize anything. Alrighty, so Next, we'll move on to bar graphs. This type of graph is a good choice when we want to show some quantity show that the quantity varies among some discrete set of items. So, for example, if we wanted to show how many Academy Awards were run by each movie, we had a x-axis of movies and just different movies, and then we had a y-axis of Oscars, which shows like how many Oscars each has won. We can call plt.bar movies, comma, num Oscars, add a title, add a Y label, add an X label, and then show it. This is exactly what we get. We get a bar graph. We have movies on our x-axis, number of Academy Awards on our y-axis, and then some other stuff like title and yeah. So, all right, again, we'll skip this for now. Another good use of a bar chart can be for plotting histograms. This can help us visualize distributions. So for example, I'm sure in classes, your professor has probably brought up a grade distribution plot before, just showing like, the amount of like A's or B's or something like that. So here we'll do that. We have a list of grades. And then here we're going to create a histogram, do just a bit of math. So it says bucket grades by decile. Okay, yeah. Anyways, so we're able to make a bar graph with an x-axis of these histogram keys and then histogram values. Each will have a width of 10, and then there are black edges for each bar. I believe this is just the RGB for it. And then, yeah, so x-axis from this to this, and then the y-axis from 0 to 5. We will add some x-ticks. You'll see what that actually looks like when we'll run it. Add some labels and a title, and then this is what it should look like. Yay, so grade distribution. Again, yeah, so pretty much everything I just mentioned. Again, you do not need to memorize any of this syntax. It will always be here for you. Yeah, so I guess there are some things that we need to note. So notice that the third argument to the PLT bar, this specified the bar width. So when we go up here, E1, 2, 3, yeah, okay. And then notice that we also shifted the bars right by 5, so that, for example, the 10 bar, which corresponds to 10 to 20, would have a center at 15. And then added black edges to make them a little bit more distinct so it doesn't like look all mushed together. And then the call to plt.axis indicates that we want the x-axis to range from -5 to 105 and leave just like a bit of space at the end. And then the y-axis should range from 0 to 5. And then lastly, the plt.xticks puts x-axis labels at 0, 10, 20, all the way to 100. So that's what those little ticks are. I guess just to make it a little bit more easy to read. Yeah, so histograms. Luckily, you won't have to manually set up your plots when you're working with data frames. We can just declare the column we are using inside the plt.hist method and define the columns inside as dfaapo. Yeah, so we will also make another parameter, which is bins. And bins pretty much means the number of columns we want our x-axis to be divided into. So for example, if your x-axis is from 0 to 100 and you declare your bins as 10, it would be enclosed in one bin, or 10 would be enclosed in one bin, 11 through 20 would be in the second all the way to the 10th bin. And so for example here, we're gonna call plt.hist on the Apple stock and set our bins equal to 20. When we look at this, again, this is our Apple stock. Bins equal to 20, so that's kind of like what it groups it as. And yeah, So, okay. Another thing we can also do is line charts. I think we did one of those already, but so it's very, very simple to make a line chart using plc.plots, and they're very good for showing trends. So here we have the variance, bias squared, and total error. Not too sure what this is actually for, but let's just say that we have these things. We can make multiple calls to plt.plot to show multiple series on the same chart. So just to show what this actually looks like. Yeah, so yeah, because we've assigned labels for each series, we can get a legend as well, which is up here at the top. And yeah, so again, a lot of it is just calling our X, Y, and asking or like specifying certain colors or adding labels. Alrighty, and then we have scatter plots. And this is the right choice for visualizing the relationship between two paired sets of data. So here we have a list of friends. Yeah, sure. And a list of minutes. And then we also have a list of labels. When we do plt.scatter and then call it as an X, call friends as the X axis and Y, our minutes as the Y axis. Let's just see what that looks like. Interesting. So this right here is the label for each point. It'll call label, friend count, and then minute count in, I guess, like a zip file of labels, friends, and minutes. We annotate each one, call the label, set X, Y equal to the friend count and minute count, and then XY text 5, -5, or I guess like just how it's shown, and add text coordinates. Yeah, so again, this is interesting syntax, but it will be here for you to refer to if you would like to make a scatter plot for your project. Alrighty, so this is a tutorial. It pretty much takes everything that we went through just now and puts it together into like a more like something similar to what you might be doing for your project. So here we will be mapping the California housing. Talked a little bit about the data set earlier. So as of now, you should have learned how to use matplotlib and the basics of Panda. In this tutorial, we'll be focusing on analyzing the housing data sets by mapping it. The perk of this exercise is that the whole visualizing can be done using a single method, df.plot. So it's also important to note that our limitation is that we are restricted to work with numerical data since matplotlib cannot plot categorical data with numerical. So there is a method to convert categorical into numerical, but it's not a part of this course. All right, so now we'll start going through the tutorial. Here, again, we have to import our libraries. And then here we have to load our file. Again, we'll be using a URL on GitHub, which is something similar to like what I showed you earlier, but it has all of the California housing data. It'll read that CSV, and then we'll call housing.head so we can actually see what it gives us. So this is kind of what our stuff looks like. We have longitude, latitude, housing median age, total rooms, and like the stuff that I mentioned earlier. It also includes some interesting things like ocean proximity and like, yeah, median income. So each row represents one district. There are 10 attributes. You can see the first 6. And yeah, so when we call housing.info, it actually gives us a little bit more information about like the range, amount of columns, and the types in each column, or the types, I guess. So we have, yeah. It also tells us like if there's if it's non-null. So I think last time you all went over like null columns and how to change that. So it provides that for us too. Yeah, so all attributes are numerical except for the ocean proximity field. Its type is object, so it can hold any type of Python object. But since you loaded this data from the CSV file, you know that it must be a text attribute. When you looked at the top 5 rows, you probably noticed that the values in the ocean proximity column was repetitive, which means that it is probably a categorical attribute. So we can call housing.describe to see like, I guess like a summary of our data set. So it'll give us like mean, median, standard deviation counts for each of the numerical columns. This is pretty cool if you're trying to, I don't know, make some conclusion about, let's say, housing median, housing median income or something like that. So note that null values are ignored. So for example, the count of total bedrooms is 20,433, not 20,640, because I guess there's around 200 null total bedroom counts. The STD row shows the standard deviation, which measures how dispersed the values are. And then, yeah, the 25%, 50%, and 75% rows shows the corresponding percentiles. Percentile indicates the value below which a given percentage of observations in a group of observations fall. So again, these are just some things that you can use, especially if you need to like come to a conclusion about your data. Now we'll actually get to visualizing it. So again, we'll be using matplotlib. In this case, we'll be using matplotlib inline, which ensures that our graphs are displayed inside the notebook cells instead of an external visualization. Yeah, so we're going to make a history of the whole housing data frame by calling housing.hist and setting the bin and fig size parameters. And then after that, again, we have to call plt.show so we can see what we just made. So when we do that, so for each of them, it actually created a histogram. So like for the longitude, latitude, housing median age, pretty much all of them. And yeah, again, this is really, really good if you need to come to some kind of conclusion about one of these, what do you call it? Like categories, I guess. So I guess there's some things that we should like make note of. So first, the median income attribute does not look like it's expressed in US dollars. So let's actually go look at that income attribute. Yeah, okay. So after checking with the team that collected the data, you're told that the data has been scaled and capped by 15. So for higher median incomes and at 0.5, actually, what? For lower medium incomes. The numbers represent roughly tens of thousands of dollars. This kind of data is common, but we should try to understand how the data was computed. So we should also note that the housing median age and median house and, values were also capped. The latter may cause a serious problem since it is your target attribute. If you want to find patterns for beyond 500,000, then we have two options. We can either collect proper labels from districts whose labels were capped, and B, remove those districts from the training set. Another thing we should notice is that these attributes have very different scales. And then finally, histograms many of these histograms are tail heavy. They extend much further to the right of the median than to the left. Although this is not our concern right now, when it comes to learning algorithms, it is a tricky situation as it is difficult to detect patterns. Again, so once we create our visualizations, there are some things that we really need to like take into account So yeah, I guess there's more to do beyond just looking at these graphs or these charts. So here we will make a histogram of the median income, and we have that there. And then we will also make a histogram of the ocean proximity. This is the syntax for doing that. This one, we wanted it to be red. This one, we didn't actually supply anything, and it was just the default color. And then here we can do plots of like scatter plot, where X is the median income and Y is the median house value. And yeah, this is really cool. So this plot reveals a few things. First, the correlation is indeed very strong. So we can see an upward trend, and the points are not too dispersed. So secondly, the price cap that we noticed earlier is visible as a horizontal line around $500,000. So that right there. But this plot reveals other less obvious straight lines. So a horizontal line around 450,000 and another around 350,000, and also perhaps one around 280,000. So when we kind of look at what I just mentioned, you can see that there's kind of like that straight line there, another straight line there, and then another straight line right here. Yeah, so again, once you're able to plot your data, there's some things that you can like see and make conclusions about, or possibly think of like different questions, like why is it that way? And that's like really, really important information when you're looking for something, or really important questions to ask when you're looking for something. All right, so next we can map geographical data. So this set actually has like a longitude and latitude columns to it. So we can actually print out a scatter plot of the different longitudes and latitudes. And as you can see, again, this is a California housing thing. Kind of looks like California. Yeah, definitely very cool. So by plotting the longitude versus latitude, we can see that it's California. However, note that it's almost impossible to see any particular pattern. The next step is to be able to separate the high density data points from lower ones. And for this, we use the alpha option in the plot function. So we set the alpha to 0.1. So you might ask, what is alpha? So matplotlib allows you to adjust the transparency of a graph plot using the alpha attribute. If you want to make the graph plot more transparent, then you can make alpha less than 1, such as 0.5 or 0.25. And if you want to make it less transparent, you can make it greater than 1. Right, so here we're going to make a scatter plot of the longitude versus latitude, and we set the alpha to 0.1. Again, here, yeah, so it is a little bit less solid, and you can really tell like the high density areas, because those are like when the dots are like kind of like stacked on each other. Yeah, so as you can see, the Bay Area and Los Angeles and a little bit is like San Diego area are like high density areas. Yeah, so we have a pattern, but it's something not as useful to us, so we can play with it a little. So here we increase the alpha a bit, change the figure size, and then also do this. Actually, let me look at this because I'm not familiar with that syntax. Oh, awesome. So here we actually have it like added colors. So set the color bar to true, and then this, I'm assuming like that more high density areas, it set it to like warmer colors than the lesser dense areas, which are blue colors. So note that we're only using pandas df.plot function. This is because matplotlib.pylot features are built in pandas, and therefore we call plt.plot. So again, this is just like syntax stuff. Again, please refer to this later. So in order to gather a little bit more information, we made the plot bigger by using fig size. We used this median house value parameter, which defines the column which we're going to base this color off of. And then this line right here is simple ascribing a color palette to C in this case. And then again, the color bar is equal to true, makes the color bar visible. Yeah, so now we have a general idea of where median incomes are high, the coastal areas, but could there also be another factor? So again, looking back at this, oh, okay, so I did misspeak. These colors are based on the average house value. Okay, that makes sense. And so again, it's more red, warmer colors over here because it's more expensive to live on the coast. So we can look at some more things. For example, here they added, what did they add? So now we'll be taking like population into account. Let that run. Okay, awesome. So they added 2 more parameters. One is the housing population divided by 1,000, divided by 100, I believe. This parameter plots the given column as a radius on the map. The reason why we chose to divide it by 100 is to make it smaller. And then they also added the label population, which is a simple label to mention what the radius is. Awesome. So yeah. By the end of this lesson, you should have a clearer idea of how to plot data frames using Matplotlib and pandas, how to make subplots and set axes, how documentation such as labels, legends, colors, and markers are added to it, how to plot bar, histogram, scatter, and line plots, how to plot longitude and latitude, and then also how to add a third data parameter with df.plot by using C. Yeah, awesome. So hopefully that made sense. Again, a lot of the syntax was very heavy, and yeah, I don't expect anyone to remember this. I know for me, when I was taking a data science class, I was pretty familiar with the syntax, but after I stopped using it every day, I kind of have to like look back to things to refer if I need to make something like this. Yeah, so there's some other things that you can look at, like plotting shapes, annotations, and drawing on a subplot. And then, yeah, and alternative methods of loading the California housing data set. But again, these are just kind of extra things, especially if you need to use them for like your project. So with that, yeah, thank you so much. And again, if you have any trouble with the homework, please reach out to Kyle, Danae, or I, and we should be able to help you. And then next week, we will be talking about the your final project and giving you guys some ideas of like what you might be able to do. Alrighty, so with that, I will stop sharing and thank you.
Thanks, Nicole.
Okay, bye Kyle, bye Lindsay. Awesome.